Hi everyone. Today we're going to study system of linear equations and we're going to solve this by elimination. To solve a system of equations by elimination, we start with both equations in standard form, meaning the x and y variables are on the left side and constant on the right side. And there will be two equations. And this is the standard form of a system of linear equations. Now, we will decide which variable will be easier to eliminate. Once we choose the variable to be eliminated, this is what we're going to do. We want to have the coefficients of one variable, and that is the variable that we chose to eliminate, to be opposites, so that we can add the equations together and eliminate that variable. This process is what we call elimination by addition. Given a pair of linear equations in two variables, here are the steps of elimination method. Step 1. Multiply both the equations by some suitable non-zero constants to make the coefficients of one variable, either x or y, numerically equal. Step 2. Add or subtract one equation from the other so that one variable gets eliminated. Step 3. Solve the equation in one variable, x or y, so obtained, to get its value. Step 4. Substitute this value of x or y in either of the original equations to get the value of the other variable. Note that in step 2, if we obtain a true statement involving no variable, then the original pair of equations has infinitely many solutions. Also, still in step 2, if we obtain a false statement involving no variable, then the original pair of equations has no solution. Example 1. Solve by elimination method. X plus 3y equals 6. 2x minus 3y equals 12. Observe the coefficients of each of the variables. Let's copy our problem down here. Notice that the coefficients of y are numerically same, but of opposite signs. In this case, we can add the equations. When we add, the y variable will cancel out. Then x plus 2x is 3x equals 6 plus 12 is 18. And then we divide by 3. That is the coefficient of x. So that we will get the value of x equals 6, because 18 divided by 3 is 6. So we have now the value of x. Now we substitute the derived value of x into any one of the equations. Let's say the first equation. This is x plus 3y equals 6. X becomes 6 plus 3y equals 6. This 6 here, we transpose to the right. It becomes negative 6. Then the right side becomes 0. We divide the equation by 3 so that y equals 0. This is the value for y. So we are done with our problem. X equals 6, y equals 0. Example 2. Solve by elimination method. 2x plus 5y equals negative 8. 3x minus 4y equals 11. We copy our problem down here and let us observe the coefficients. Note that the coefficients of each of the variables are numerically different. In this case, we can decide which variable to eliminate. Let's say x. We're going to multiply equation 1 by coefficient of x in equation 2. That is the number 3, and vice versa. It means the first equation we multiply by 3, the second equation we multiply by 2. So the equations becomes like this. The first equation multiplied by 3 becomes 6x plus 15y equals negative 24. Second equation multiplied by 2, it becomes 6x minus 8y equals 22. Now we see that coefficients of x respectively are now numerically same. Therefore, we will subtract the equations. Remember, when we subtract, we need to change the sign of the terms of the second equation. The 6x here becomes negative, negative 8y becomes positive, the positive 22 becomes negative. Then we proceed to addition. 6x plus negative 6x is cancelled. 15y plus 8y is 23y. Negative 24 plus negative 22 is negative 46. And we want to get the value of y, we divide the equation by 23. So y equals negative 2. We have now the value of y. Then we substitute the value of y in any of the equations to get the value of x. Let's say equation 1. So 2x plus 5y equals negative 8 becomes 2x plus 5 times the negative 2 equals negative 8. 5 times negative 2 is negative 10. Then we transpose the negative 10 to the right. So 2x equals negative 8 plus 10. The right side becomes positive 2. To solve for x, we divide the equation by 2. So x equals positive 1. This is the value of x. Example 3. 5 years ago, Nuri was thrice as old as Sonu. 10 years later, Nuri will be twice as old as Sonu. How old are Nuri and Sonu? We let x to be Nuri's age. Y equals Sonu's age. Now the condition 1, 5 years ago, Nuri was thrice as old as Sonu. Let us represent the 5 years ago with respect to the age. So for Nuri, that is x minus 5. For Sonu, that is y minus 5. And it says, Nuri was thrice as old as Sonu. So to balance this, we will multiply 3 to Nuri's age. Then, let us simplify the right side. 3 times y is 3y. 3 times negative 5 is negative 15. From here, we transpose 3y to the left. This negative 5 we transpose to the right. So we have x minus 3y equals negative 15 plus 5. Right side becomes negative 10. Now condition 2. 10 years later, Nuri will be twice as old as Sonu. Again, we represent the age of Nuri as x plus 10. The age of Sonu 10 years later will be y plus 10. It says again, Nuri will be twice as old as Sonu. So we multiply 2 to the age of Sonu. Then we simplify the right side. 2 times y is 2y. 2 times 10 is 20. Then this 2y we transpose to the left. The positive 10 we transpose to the right. So we have x minus 2y equals 20 minus 10. The right side becomes 10. So we have now the two equations. This is equation 1 here. This is equation 2. Let's put them together. Now we can see that coefficients of x are numerically same. We can subtract the equations. In doing so, we need to change the sign of the terms of the second equation. X becomes negative, negative 3y becomes positive, negative 10 becomes positive. Then we add. X plus negative x will cancel out. Negative 2y plus 3y is y. 10 plus 10 is 20. So this is the value of y. We said that y is Sonu's age. It means Sonu is 20 years old. Let us substitute the value of y in any of the equations. Let's say the first equation. The x minus 3y equals negative 10. So we substitute it here. X minus 3 times 20 equals negative 10. Negative 3 times 20 is negative 60. We transpose this negative 60 to the right. So x equals negative 10 plus 60. And the right side becomes 50. So x equals 50. In the beginning we said that x is Nuri's age. So Nuri is 50 years old. An example. Solve the system of linear equations by elimination. We have the two equations. The first is 2x plus y equals 7. The second is x minus 2y equals 6. There is a note that if any coefficients are fractions, clear them first by multiplying the equation by LCD, or the least common denominator. But in our example here, there is no fraction. So let us proceed with step 1. Check out which variable is easier to eliminate. We have the variable x respectively for the two equations and the variable y for the two equations respectively. And our goal here is to make the coefficients of the chosen variable to be same but opposites, meaning they are of opposite signs. Let us copy these two equations down here. Let us name them to be first equation and second equation. As for our discussion, I would like to eliminate y for the reason that they are already opposite signs. However, they have different coefficients. So let us do some manipulation. This is the general rule. Multiply the first equation by the numerical coefficient of y in the second equation, and vice versa. It means to say, since I decided to eliminate y, in the first equation, I will multiply the first equation by the coefficient of y in the second, which is 2. And in this case, I will not include the sign. And also, for the second equation, I will multiply this by the coefficient of y in the first equation. And in this case, it is 1. So we have now the first equation to be multiplied by 2 and the second equation to be multiplied by 1. Simplifying the equations, we have this 2 times 2x will be 4x, and 2 times y is 2y, equals 2 times 7 is 14. While the second equation, if we multiply by 1, will just be the same. That is the x minus 2y equals 6. And from here, let us add. Look at our variable y. We have positive 2y and negative 2y that we can simply eliminate or cancel. And then let us add the x and the x. So we have 4x plus x will be 5x. And the right side, this is now equal to 14 plus 6 is 20. Now let us solve for x. Let us divide this equation by the coefficient of x, which is 5. If we divide this equation by 5, the coefficient of x will be 1, which means we can simply copy the x down here, and on the right side, we have 20 divided by 5. And simplifying this, the quotient is 4. So we have a value of x as 4. And then, let's go to step 2, and that is to substitute this value of x to any of the original equations to get the value of y. So we have two equations here. Suppose we choose the first equation. The 2x plus y equals 7. And then, let us now substitute the 4 to that x. So we have 2 times 4 plus y equals 7. This 2 times 4 will be 8 plus y equals 7. Let us transpose the number 8 to the right side. The sign must be changed. So this is positive, it becomes negative. So we have now y equals 7 minus 8, and this is equal to negative 1. So y equals negative 1. Let us write the x and the y as an ordered pair. So we have 4, negative 1. And this is the solution of our system of linear equations here. Now let us check if this answer is correct. Let us substitute the solution to both equations and must make those equations as true. Let us take the first equation, 2x plus y equals 7. Let us substitute the 4 into the x and the negative 1 to y. So we have now 2 times 4 plus negative 1 must be equal to 7. 2 times 4 is 8 plus the negative 1 equals 7. 8 plus negative 1 is 7 and equal to the right side, which is 7 also. So the 4 negative 1 makes the first equation true. Let's try the second equation. The x minus 2y equals 6. Let us now substitute the values. So now the x becomes 4 and this y here becomes negative 1. So we have 4 minus 2 times negative 1 must be equal to 6. So this is now 4. This negative 2 times negative 1 will be positive 2 equals 6. And 4 plus 2 is 6 and that is equal to 6. So it is correct. So again, the solution makes the second equation true. It means to say, we are sure that our answer here is correct. And this is our final answer.